Hi everyone, my name is Vincent Reniers. I'm from KU Leuven in Belgium, and today I will be presenting my schema recommender for NoSQL document databases. Okay, so if we take a look at the database landscape, it has become quite diverse in the last several years, and it's no longer solely dominated by relational database systems such as MySQL, but we also see NewSQL and NoSQL type of database systems. It's in this category of NoSQL that actually also data models have become quite diverse. So the schemas in which we design for are quite diverse, and they feature graphs, key values, but also columnar structures, which are tables in fact. But in this category, I will be focusing on document databases such as MongoDB, which feature a more JSON-like flexible data model. Now, what exactly is the challenge with modeling the data model or modeling document database schemas? It's actually in fact that they prefer a more aggregate style of modeling. So if you look at the example here, we see customer N, which has ordered several items, and we also see some of her payment information. In this case, we have merged all of this information together in a single record so that it can quickly be served to N when she looks it up. So in a single read lookup. This greatly benefits read performance, but it comes at the cost of data redundancy. Since, for example, if we group multiple information like this together, the customer N's information might become duplicated across multiple documents, multiple orders. So while this benefits greatly read performance, it comes at a cost of data redundancy. And it is here where actually the normalized form traditionally applied in MySQL or relational databases, that this form actually optimizes for minimizing data redundancy. So it's in fact that there is a good middle ground between both approaches, having some data redundancy but not too much. But it's actually really hard to decide for your specific application and your specific workload, what would be the best combination to make between entities and relationships? Which entities and relationships would be best to group together, and which not, of course. So in light of this, I have come up with a schema recommender for document type of database systems. There are also other schema recommenders for example, columnar stores. But this one is state of the art for document type of systems. So here, a brief architectural overview of the recommender. As an input, the recommender takes a conceptual data model schema of your application and a set and a read workload as a set of join operations. The user can then also specify some run configurations, for example, limit the bounds of the solution, how deep is the possible nesting, or etc., or how long should the recommender run. These inputs, data model and workload, will then be parsed into the generator, and we will initialize the generator by forming a set of initial data structures which are normalized and initial set of root query plans. How this exactly happens is that we take a join query, and for example here in the case of users that are merged with the products that user sells. For the user query, we will create a document users, and for the product query, a document products, and each document will only contain the attributes that were selected in that specific query of the join query. We will do this for each join query, so that we'll end up with multiple initial normalized document structures. After creating our initial data structures, we then look at each join query on all the possible pathways that we can now answer this join query, and we will formulate this as root query plans. So this is the initialization, and of course we have somewhat worst case scenario where joins are still quite slow. So we will start to optimize query plans by removing a join step. We take a random query plan, in this case users that are joined together with products that the user sells, and the comments that were made by previous buyers on these products. We will then optimize, and this will yield two documents that are quite larger. So we will get users that have the product information embedded in the same record, the products that user sells, of course. And we also end up with a document or a table, a document that embeds product information and embeds the comments that were made by previous buyers. So this query plan can then now be executed with only two steps, two queries rather than 3 actually. Other query plans are then also notified of the existence of novel data structures, which in turn then evaluate whether or not they can make use of them. And this will also yield new query plans. So this loop makes larger, more workload efficient documents, but also will yield more and more query plans. After which point, a certain point will come where the query plan stack size that still require optimization might become rather large. So at a certain threshold of say 80,000 query plans, we will apply some pruning, and we will sort query plans from least to most effective and prune the least effective ones. We can do a similar approach for documents as well, pruning the least efficient documents. This configuration will go on for quite some time, and we will apply intermittent pruning, but eventually, after reaching a certain number of iterations or completely stopping, we will then apply our final pruning step. And for example, if the user desires 10 tables, 10 document collections, we will prune until we have that amount, only preserving the most efficient document schema. So this will then yield our schema recommendation. It will feature, the recommender will output a set of document collections, and also a set of query plans on how you can answer each original join query. This query plan will also specify whether or not it requires secondary indexing. And thirdly, the recommender will output a matrix which provides insights on the costs of the query plans involved, but also the documents, and also very importantly on how efficient the document is globally in answering the workload. So it provides some good insight. And with this, I would like to conclude, having presented you a brief overview of the recommender. But for more details, I would highly recommend you read the paper or view the full presentation, since the optimization step is quite complex, since it merges together larger document trees, but also on the more intricate details of the cost models involved and the ranking functions. And of course, also more information on the evaluation of the generation and pruning step, but also the performance. Thank you very much for listening. And if you have any questions, feel free to ask. Thank you very much.